Yeah.
I'm getting the quiz open right now.
Okay.
Yep.
Sorry, I'm just brushing my lashes, by the way. I'm such a girl.
Yep. It's taking forever here.
What'd you say? You're such a girl, Jocelyn? Well, that's a good thing.
I know, but I'm just not. I don't know. I'm not really a girly girl.
Okay.
So when I do have my girl moments, I'm just like, this isn't natural for me. I don't know.
That's hilarious.
It just like throws me off guard sometimes. Because like the only thing I'm really like a girly girl about is my lashes and my hair.
I can tell your eyelashes are so pretty.
Thank you.
Are they natural?
No, I wish. I get eyelash extensions.
Oh. Yeah, they're like so long and so pretty.
She gets a discount on them, huh?
I definitely get a yeah, I don't even pay for my lashes.
Hey,
Wow.
Can't blame you.
Yeah, it's nice. It's pretty nice. I'm just basically the lady that does them for me. She's like, you're just going to be my walking billboard. Yeah. Anyways. Were you guys able to pull it up?
Yeah, I got it here.
Yeah, me too. I just need to open the applet.
Okay.
Is that your little one, Abraham?
Yes. He likes English.
Oh,
Really,
lovely.
Like, what? We were on meeting with some other missionaries of Pathway, and there was a sister, and Ezra was trying like
Look at how cute he is.
Oh.
He's got a lot of hair too.
Yeah.
He's a cutie. Okay. So, number 1 and 2 obviously are true.
Right.
Yeah.
Number 3. It says use the normal probability applet to find the combined area under the standard normal curve that is to the right of z equals 1.358 and to the left of z equals that negative. So
I get an answer of 0.175.
That's what I got as well.
Okay.
Does everyone agree with that?
Yep. I just opened the applet and yep, that's what I got.
Do you agree, Abraham?
How did you do that? Oh, okay. Yeah.
You have to use the applet.
Is this recording, by the way?
Yes.
Oh yeah, I don't. Oh, okay, good.
Good. All right. Number 4. Which of the following will have a smaller standard deviation if 9 observations are randomly drawn from a population? I think it's the second one.
Yeah.
Yeah, the distribution of the sample means.
Yes.
Okay, number 5. Which of the following results implies that the spread in that decreases as the sample size increases?
The central limit.
Is it a lot of large numbers?
I think it's a lot of larger numbers.
Yeah.
I didn't read about that. Did they have a law of love? Was it in this chapter?
Actually,
No,
it was
it
in the
was
last chapter.
Was it last
Yeah.
chapter? I don't remember reading
Yeah.
that. I'll have to go back and reread it.
Yeah, it's just under the central limit theorem.
Okay. I believe you. I'm going to put it there, but I just need to go back and reread it so that I understand it.
Yeah. Number 6.
Okay. So Diane earned a score of 160 on the quantitative portion of the GRE. What is the Z-score corresponding to Diane's score?
We have to use the formula for the E-score, right?
Yes.
Okay.
So let's see here. The information is above. So U equals 150.8. And if she got 160, so it's 160 minus that, divided by 8.8.
All right. Walk me through that formula again, Jocelyn.
So it's just kind of the same as last week.
Uh-huh.
So she earned a score of 160.
Uh-huh.
So it'll be 160 minus the
Minus
mean,
1.
which is 150.8,
Okay.
over 188. Or sorry, 8.8.
Mm-hmm. And I got 1.045.
That's what I got as well.
Okay.
Okay, so it's 160 minus 150.8 divided by 8.8.
Yes.
Exactly.
Okay. Okay. And what's the answer that you got?
1.045.
Okay.
Dile que soy un multimillonario. Ahorita no.
Okay, so then we put that number into the applet then for number 7, right?
Sorry?
For number 7, we put that 1.045 into the applet to see who would do above 160, right?
Yes.
All right.
160?
Mm-hmm. So you would do the Z-scores as 1.045, and then you would select the part above.
Yeah, so it's 0.148.
That's what I got as well.
1.58.
You got what? I'm sorry?
I'm kind of confused because it says, what is the probability that randomly selected student will score and 60%? So we got already in number 6 1.0545, right?
Yes.
Yeah.
So in the applet, we're going to put that number in the Z-score.
That's correct.
Okay, so are we going to select what part?
The part above.
Yeah, so you want the very right section of it.
The right section.
Just the right section.
Okay, so it's going to be 0.48. 1.48. Okay.
Yep.
All right.
Do you
The
agree with that?
area on the right,
Yeah, only the right one.
I think I made a mistake. Because I got an area of 0.412.
You have to only select the right side.
Right, just click on the right side. The right side should be the only one with color.
Mm-hmm.
That's what appears.
You want me to share my screen?
Yes.
Yes.
All right. 1 sec. Okay, here. Only select this part. So you got the number.
Okay.
0.148. Only select this part. Can you see it?
Yes. Okay, yeah, but on the C
You
score,
have to put
code.
the C-score we got in number 6. So
Okay.
1.045, and you're gonna get the area, which is 0.148.
Excuse me.
Okay.
It's okay.
Does
Makes
that make
sense now?
sense? Sorry?
Yep.
What were you saying, Mike?
I was just asking if it made sense.
Oh, yeah.
Oh, yeah, it does. Thanks.
Okay.
All right, perfect.
Okay.
So what is the Z-score corresponding to the sample mean of student scores, or of the student scores? And then it says round your answer to 3 decimal places. So you have to find the mean first.
We have to put them in order.
Oh, yes. We need to get a spreadsheet going here for this.
I don't think we need to find the order. We're just trying to find the mean.
You don't think we need that to find the mean?
No,
I think the mean is gonna be
because it's the
160.
average of all of it. So
Isn't the mean 160?
Yeah, that's
Or
what I got as the mean.
160, right?
Yeah. So again, it'd be let's see. Is there a different part to that?
Oh, it's the average, dopey. So the mean's the average, right?
Mm-hmm.
Yeah, the mean is there.
Average is 160.
Mm-hmm.
I keep getting mean and median mixed up.
Yeah, me too.
Yeah.
So the mean is 160,
Mm-hmm.
Mm-hmm.
and then we have to find the standard deviation.
We can use a formula on the spreadsheet. So.
Okay.
So if we put those numbers, we're gonna get them. So
Standard deviation is 10.04, 10.05.
10.05.
Mm-hmm.
Okay.
Or if we have to go 3 decimals, yeah, 10.050 is the standard deviation.
That is not our answer, though.
Let me check. I'm gonna put mine here.
I mean, that standard deviation is probably right.
Uh-huh.
It is right. But the answer where we're dividing the standard deviation from the mean, that's not our answer. I don't think that's right. Or the answer to this question particularly.
Yeah, it's not that. I was just getting, because we need the standard deviation for it to figure it out.
Yeah. Shoot. Okay. So I'm gonna assume.
I got like a standard deviation of 8.988 using the spreadsheet. So I don't know if that's right.
Yeah, I got using the spreadsheet. I got a standard deviation of 10.050.
But there are 2 standard deviations. One that it says point P, and the other one it says point S. So I'm not sure which one is the right one.
Right.
let's see.
Let me see.
So what were those numbers again?
160,
Mine?
170. Oh, the numbers for the standard deviation or the numbers that I got?
The numbers that are given.
Okay, 160,
Yeah.
175,
Okay.
163,
Okay.
149,
Uh-huh.
and 153.
Perfect. Thank you. Okay. So for the sample standard deviation, I got
Mhm.
10.05.
Right.
The population standard deviation is that 8.99 that you
So
got.
all right. How do you figure? So are we dealing with the population standard deviation?
I think we're sticking to the sample standard.
Okay.
deviation.
Yeah. So it's
So
gonna be
10.05.
10.05.
Yeah.
Yeah.
All right. So now we have to
Okay.
figure out the z-score
Z-score.
for those with those numbers.
Yes.
So we have them
And I'm
for
looking at the book right now.
So it's gonna be 5 minus. No, I'm kind of confused right now.
Yeah, that's why I'm looking at the book here.
Okay.
I'm reading in section 3 of tonight's reading.
Section 3. Problem is involving mean. So it's gonna be the value minus the mean. By the standard deviation.
Standard deviation 2.45. The Z-score.
You guys, it's February.
It is.
Woohoo!
Yeah, it
It's
is.
Groundhog Day tomorrow.
Yes, it is.
The formula is on number 3.
Mhm.
What is the formula?
Is that right? Like C equals value minus mean over standard deviation.
I don't think it's that one because it would say Z for Z-score. But I could be
Okay.
wrong.
No, that does give you the z-score, though. I think
It
he's
does?
right. Yeah.
Okay.
If you look at the book right there, that does give you the z-score.
Yeah.
Yeah.
Okay, so what was that formula again?
C
Value
equals
minus
value minus mean over standard deviation.
So the same one we've been using.
Yeah.
Yeah.
So, but how do we get the value? What are we using as the value?
I was thinking that maybe the value is gonna be.
Well, we do
Oh
have to have
man,
a value because
Right.
just the mean
doesn't say
divided by
anything.
standard deviation is like 15 point something.
Because if you keep reading, it says work finding the area under a normal curve based on a sample mean.
Okay.
It's before the picture
Right. Yeah.
green of of grass.
Under.
Okay, so it would be a sample size of 5, drawn from a population with a mean of 7. So our mean is 160. So it would be 5.
But what is the value?
Right, that's what I'm trying to figure out.
Because
I'm gonna try using as a value the maximum number, which is gonna be 175. So 175 minus 160.
135 or 153?
I'm not sure.
Yeah, so Glenda, where are you getting the 135 from?
I was just getting the 175 from the.
You were
from the
using
sample.
175. I'm sorry. I thought you
Yeah,
were saying
from the sample,
135.
like that's the maximum.
Right,
So
I
if
follow
we
you.
take that number, let me see, divided by the standard deviation, which is 10.05, we're gonna get 1.493. But I'm not sure if that's the right one.
That seems right.
Wait.
The problem is they don't give us what the population size was. That's where the problem is coming in.
Is there any formula to get the value from the mean and the standard deviation?
What about? Because if you keep reading there, we can use this information to find the probability that the sum or the population will be greater than 10.
Yeah.
So if we use the same philosophy there,
Found
so
the
it would
answer, not the
be 10 minus
way.
5.
What were you saying, Abraham?
Found the answer, but not the way they did.
And what's the answer?
3.8.
What?
Answer is 2.8.
0.8.
2.8?
Yeah, 33 and then an 8.
2.338?
But how come?
That's a very good question.
Okay. Okay, we're gonna figure this out. So,
That kind of looks like a riddle. Ugh.
Yeah.
there's no value. How do we find it?
Oh, wait, we need to back up a little bit. Okay. Because it gives us everything up there. Because we still have to use that 150.8 and the 8.8. Because it's supposed to be for questions 6, 7, 8, and 9.
Oh, lovely.
Yeah, we have to use that information that's there above question 6.
Mm-hmm.
Scores on a quantitative portion of the GRE are approximately or normally distributed with a mean of 150.8 and a standard deviation of 8.8.
Okay, so mean
Mean is 150.8
and a standard deviation
of
8.8.
8.8.
Okay. But what is still the value?
Right.
So, would the maybe it is
160?
Okay. Yeah, if you read down below the graph where we were reading at,
Mm-hmm.
where it says worked example, I think there's where our answer lies.
Mm.
So we have the mean of that sample is 160,
right.
and then we have to use that standard deviation. So it's the 150.8 is the standard. Is the standard deviation is 8.8.
Mm-hmm.
But then, are we putting together both means and both standard deviations?
That's what I'm trying to figure out.
Because Because what did you say the answer was, Abraham? 2 point what?
33.8.
Okay, so that's our goal. Our answer goal. Let's see, 160 minus 150.8 over 8.8. That's
Right.
I got 1.045.
For that?
Yeah. I use the 160 minus 150.8 divided by 8.8, and I got 1.045.
Okay, well then that's not it. And so even with the other stuff, that's definitely not going to be it. I'll just make that number smaller.
Oh, wait. Okay.
What are you thinking?
All right. So let me take a look here. The mean. The weekly cost for that.
Excuse me.
Okay, I'm showing my screen. This here talks about a sample size.
Yeah.
The sample on question 8 is 5 students.
Right. Sample size will be 5.
Mm-hmm.
And we'll use this formula, maybe we could get something.
Okay.
But I was confused. Which mean and the standard deviation are we using?
Well, we have to use the because on the quiz it says when if you go up above 6, that we have to use that information for the next 4 questions. So that would be 6, 7, 8, and 9.
Okay, I will try to do for both and see what happens.
So, let me check. So if we get 160 minus 150.8 divided by... Because in the other formula, they're using the root square of the number. So we have a number that is 5, right? So O is going to be the standard deviation. So that's going to be 8.8 divided by the root square of 5. Hopefully this is going to work. 2.338. Gotcha.
Okay, so show us how you did it, Glenda.
Okay. I did it in my calculator, but I'm gonna write it here in the worksheet so you can guys see it.
All right.
Okay.
Awesome.
Okay.
Let me share my screen. Where it is?
Did you use the same formula we were talking about?
Yeah. So yeah, but I was seeing that it has something with the root square. So, okay, I just
Oh.
put 160, which is the value, minus the mean that is 150.8. And then it's going to be divided by a.8, which is the standard deviation. But this is going to be divided by the root square. I don't know how to put the root square in Excel of the number, which is 5. And you're going to get 2.33a.
Oh,
I don't know if you guys understood that.
Yes.
So
yes.
I use this formula.
Okay. So you did 160
I use this formula right here.
minus 1.150
So here,
divided.
okay.
this one. So I use the standard deviation, which is 8.8, divided by the root square of 5, which is the number, because it gives you the sample number. So that's how I got 2.338.
All right. So then it's 5. Oh,
It's gonna be
put your screen back up there, Glenda.
Okay. Here,
Okay.
160 is gonna be the value. Minus
So then it's
1.8, that's gonna be the mean.
That makes sense.
And divided by the standard deviation, 8.8. And you're gonna divide that by the root square of 5.
Okay, because it's not working out for me. All right, so I get.
Because you have to put a parenthesis between here.
Yeah, so I'm doing a parentheses 160 minus 150.8, closing that parenthesis.
Close.
And then dividing, and then opening another parenthesis, 8.8 divided by 5, closing that parenthesis.
No, the root square 5.
The square root of 5.
Oh yeah, right, yeah. I just don't know how to put it here with my Excel, so that's so.
Did you got 2.338?
Yep.
But
yep.
I got
2.3377, but I rounded to 8. You got it, Jocelyn?
Yeah, I did.
You got it, Mike?
Oh, okay. I was doing it by 5, and so the square root is actually 2.236. So that makes a difference.
Oh, okay.
Okay.
Okay, so we got that one.
2.33. So is it rounded or is it just straight 2.33?
I think we have to round it to 3 decimals places, so it's going to be 2.338.
Yeah, what I was doing is I wasn't taking the square root of 5. I was just taking 5, thinking that there wasn't a square root of it.
No, we have to use it though. So. Okay, so 9 says, what's the probability that 5 randomly selected students will have a mean score that is greater?
What does number 9 say?
It says, what is the probability that the 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem?
Okay, so then we just put the 2.338 in the probability.
Apply it.
Yeah.
And it's 0.0097, so 0.001 or
oh, we have to. Oh, it says just keep it that way, right? It says 4 decimals.
Does it say four? Does it say 4 places?
I think so. Let me see. See, yeah,
No,
it says round your answer to 4 decimal places.
Oh yeah, so 0.0097.
Perfect.
Yeah. 0.0. What is it? 0097.
Yeah, it's correct.
Okay.
Okay. Does everyone agree with number 9?
Yes.
Yep.
Okay. What is the shape of the sampling distribution of the random variable, which represents the sample mean of the 81 students who are selected?
So let's see. Random.
I want to say it's normal.
Lately normal.
Yes,
Yeah.
it's gonna be normal because if you remember from the
Yeah,
last
last
time,
week.
right?
And
It's
you
gonna
did
be
great on
normal.
30.
Yeah.
Okay. 11. What is the mean of the distribution of the sample means for all possible samples of size 81 that could be drawn from the parent population?
What is the mean of the distribution of the sample means? But the mean, isn't it the same as the sample means?
No.
Yes.
Yeah. Yes.
So it remained at 3.5.
So
What is it? 3 point?
3.5.
Yeah.
3.5. Yeah. Because from last week it says that the mean is going to be the same as the
Right.
the sample mean. 3.5. Are you guys agree with it?
Yeah, I agree.
Yes.
Absolutely.
Okay. Okay.
Okay. What is the standard deviation of the distribution?
Okay, so that's gonna be the standard deviation divided by the root square of the number. So standard deviation is 0.7 by the square root of the sample number.
0.7.
Yes, yeah, 0.077. How many
All right.
decimals do
So,
we have?
are you using that same formula there?
No, I'm using the last week formula, which is
Oh, okay.
standard deviation divided by the root square of the number.
Okay.
Of the mean?
No, the number of the sample.
Oh, okay. Okay.
It's gonna be 0.078.
Is that the answer, Abraham?
I'm doing it, but do I need to first do the root square of 81, right?
No, yeah.
Would be
So it's gonna
9.
be 9. Yeah. So 0.7 divided by 9 is gonna be 0.078.
Yeah.
That makes sense.
Correct.
Okay. I don't feel that lost tonight. Woohoo! I've been working a lot, so yay.
All right. So then because that's our z-score right there, isn't it?
Mm-hmm.
All right. So that 0.078 we just put in the probability applet.
Okay.
Yes. And then just select the less than 3.3.
It's going to be 0.468 or 0.469.
Yep. 0.469.
0.46. Is that the
Okay.
answer, Abraham?
Yes.
Yeah, that's the left side of the curve.
That's gonna be for question 13, right?
Yes.
Okay. Abraham, do you have the same answer?
Yes. But when we rounded, we
Mm-hmm.
got the 9.
It's gonna be
But is that the
point.
answer it gave on the one page where you found the answers?
I can't see them.
Oh, okay.
After question 9, I can't see them.
Okay, that's fine.
469,
We'll just see.
right?
Yeah,
Because we are gonna round it.
0.469 because it's 0.4689.
Uh-huh.
And we round, so it goes to 0.469.
Perfect.
0.469.
Yes.
Okay. All right. Number 14. What is the probability that the mean GPA for 81 randomly selected students will be greater than?
Okay, so that's gonna be the right side.
Yes.
Yes.
Okay.
It's the same number.
The same.
Yeah.
Yeah.
Which is weird.
That is a little weird.
Let me take again. But the 0.078, that's going to be the standard deviation of the samples. So that's not going to be the z-score.
That's not the z-score. You're right. You're right.
So we need to find the z-score.
Yeah.
Go from there. Okay, so the 0.078 is the standard deviation, you said?
Standard deviation, yeah.
So, I'm just gonna go.
Well, but that's the standard deviation for the samples. So we need to
81.
So it's 81 minus what was the mean? 35?
It's still 9.
The mean.
The root square for 81.
The mean is 3.5.
3.5.
Okay. So, let's see. 81 minus 3.5, 77.5 divided by 0.078, 993.5.6.
What?
That's what I got. If the sample size is 81 and the mean is 3.5,
right,
and the standard deviation is 0.078.
And do we have a number of the sample? Well,
that's the answer I gave.
We have.
Well, just put it in. Let's see what.
Look, but you're using the standard deviation of the samples, and I think we have to use a 0.07, which is just the standard deviation of the population. Let me see.
Or are we supposed to do it like the last one, where we had to square root one of the standard deviations?
Because the 81 is going to be the number of samples, so.
The 81 is the value. So.
Okay, it's 81.
81 is the value. 3.5 is the mean.
And
no. Less than. Oh, okay. I know what we're doing wrong.
What are we doing
Tell
wrong?
us.
So we're looking at the wrong thing. We're looking at the wrong mean. It says, what is the probability of the mean GPA for 81 randomly selected students that will be less than 3.3? So instead of 81 being the value, 3.3 will be the value.
Oh,
So
so 3.3 minus 3.5 divided by 0.073.
It'll be, so the z-score is negative 2.564.
What was it again?
Negative 2.564.
So if we put that on the applet, negative 2.564.
0.005 is what we would get then.
Okay, so then that's our answer for number 13.
0.052.
We only need to go 3 decimal places.
Okay, so 0.005.
Correct.
Okay.
And then in turn, the probability that it will be greater will be the 0.995. Yeah, because that will equal out 1.
Which one is the other one?
The answer for number 14 will be 0.995.
Oh, yes,
Okay,
yes.
you have to, okay.
Because we're
got it.
We're just trying to equal it out to 1.
Okay.
Here we go, overthinking it again.
Yeah.
Yeah.
Okay.
Perfect. Oh, guys, one more.
Yes.
Hang in there.
All right. The U.S. Coast Guard assumes the mean weight of passengers in commercial boats is 185 pounds. The previous value was lower, but was raised after a tragic boating accident. The standard deviation of passenger weight is 26.7 pounds. The weights of a random sample of 48 commercial boat passengers were recorded. The sample mean was determined to be 177.6 pounds. Find the probability that a random sample of passengers will have a weight that is an extreme or more extreme, either above or below the mean than was observed in this sample.
This sounds like a fat joke.
That was funny.
Thanks for the levity. We needed that.
Okay.
Okay. So what mean are they going to be talking about there? Are they talking about the 185? Or are they talking about the 177.6?
So I'm assuming what is going to happen is 177.6 minus the 185 over 26.7. If that is the case, I don't think that's right though.
So how are you setting it up? The 185 minus 177 or the other way around?
177.6 minus 185 because the 185 is the mean.
Right.
So that top part will be negative 7.4. Then we divide that by the 26.7. That gives us a score.
I get 0.277.
That's what I got as well.
Yeah, me too.
Okay. So that
So
would
we
be the
put
Z-score.
that.
So what is the area? This what?
0.
Yes. Need to figure.
0.277. The area is going to be 0.390.
What is it?
0.390.
391. If we
round
it up,
round it.
391. 0.391 is that it would be more extreme.
Okay.
Does that seem right?
I don't think so.
So it says, note, as extreme or more extreme means that are not only interested in values that are lower than ones we observe, but also values that are as far away from the mean as ours in the positive direction. So what is just the two outside parts? The area of just the two outside parts.
The two outside parts?
Yeah.
Would be 0.782.
Yeah, 0.782.
Okay, what about just the middle part?
0.218.
And then what about just the lower part?
0.609.
Okay. So our answer could be one of those.
Love the optimism.
But we only have to figure that out. Which part?
Yeah.
Right.
Okay. Find the probability that a random sample of passengers will have a weight that is extreme or more extreme than was observed in the sample. Okay. So first score is that. Then what does the book say? Let's see.
Guys, I think I got it. Okay. So if we read again, it's giving us the number of the sample, which is 48. So we really need to use that. So I got 175.6 minus 185 divided by 26.7 divided by the square root of 48, and I got negative 1.920. I put it on the applet and I selected the right and left side and I got 0.055.
That's correct.
So what was your Z-score that you put in there?
negative 1.920.
And you got 0.055?
Yeah, because you are selecting
Right.
both the right
Selected the
side
two
and the left
outside ones.
side.
I was
Yeah.
just about to look. I was just looking at that equation.
Mhm. We were just missing the number of the sample.
Right.
Okay. Well, I'm.
Are you agree with that?
Yes.
Yeah.
Because we had to take the square root of that 43, like you did.
48 actually.
Yeah, 48.
Okay, so we all agree on 0.055.
5.5.
Yeah.
Yeah.
0.055.
Let me turn mine in real quick.
Okay.
Okay, we got 100.
Sweet. All right. So for next week, with my schedule going back to where I'm working 12 to 9, do we want to try doing both tests on Tuesday?
Yes.
So
Yeah.
so we'll meet once.
It's okay. We can
I
do it on
got
Tuesday.
wrong question 5, but I think it's correct.
Question 5 is the law of large numbers.
Yeah. Oh, okay. Yeah, that was my mistake.
Okay.
Abraham, does Tuesday next week work for you for both lessons?
Yeah, it was.
Perfect. I'm so excited, guys.
Yeah, me too. What time? Same time?
If
Same
5
time.
works for everybody, we'll do 5.
Yeah. Same time, 5
Mm.
o'clock Tuesday.
Yep. I mean, because
Okay,
I'm
guys.
off all day on Tuesday, so it's actually up to you and to Glenda and Abraham.
Can
What
we do
about
it
you?
just a little later? Because I got to work at like 4, so I have to run to get home.
Okay.
That's
Does that
fine.
work for you,
So
Jocelyn?
You can tell
Yeah.
me.
Okay.
what if we can do it at like a little later?
Do you
At
want to do like 5:30 later or like 6 o'clock later?
6 finds best, so I'm not gonna be in a
6?
rush to get home.
Okay.
Yeah.
We can do 6.
Okay.
So
All right.
Perfect.
Okay, guys, it's a date.
All right. 6
Woohoo!
o'clock next week. Thanks, guys.
Bye,
Awesome.
guys.
Have a good night.
Thanks. Bye now.
Thanks. Bye.
Bye, guys.
Bye.
Bye.
Okay.